Hi, I'm Tucker, and I decided to tackle the Fintech choosing a cloud service provider case. The reason I chose this case is that I wanted to learn more about implementing cloud systems in financial companies, and I thought it'd be interesting to analyze a company in the alcohol industry. So what is Fintech? Fintech is a business-to-business, or B2B, alcohol payment processing system that tracks payments between manufacturers, wholesalers, and retailers. Because their system relies heavily on self-reporting, Fintech suffered early on from data cleanliness issues. For example, the name of a beer was often misspelled or was assigned an incorrect data label. This led Fintech to create a proprietary algorithm that sorted and cleaned data for easy interpretation by its customers. The only issue is that Fintech has all of their data hosted locally, which made it inefficient and costly to provide customers with the data. It was a significant burden on the consumer side to have to jump through extra hoops. Moreover, Joe Kuo, the chief information officer of Fintech, realized that in a few quarters, Fintech's own data storage capabilities would be outmatched for the amount of data they will accrue on behalf of their customers. Instead of opting to improve their own infrastructure, Joe Kuo decided that it would be beneficial for Fintech to migrate their data processing and storage system to the cloud. Kuo assigned one of his employees, David Nolte, to review the best options for moving forward with a cloud service provider. Nolte and his staff concluded that the three industry leaders in terms of cost and reliability, both of which were important to Kuo, were Google Cloud, Microsoft Azure, and Amazon Web Services. To better understand the differences in the cloud service providers, we need to quantitatively compare all the things they offer. As far as their SDKs, IDEs, and source controls, they're all very similar. AWS does differ a little bit because it just does code commit instead of GitHub, but they all use similar toolkits and SDKs. Their databases are all accessible via SQL, but Amazon by far has the most options. Whereas Microsoft only has SQL Server and Google Cloud only has Cloud SQL, Amazon offers SQL Server, Amazon Aurora, Amazon RDS, Oracle, and PostgreSQL. All three providers have greater than 99% availability. They also all have a service credit for downtime. With regards to more qualitative stuff, all three providers have local IT and analytics staff. They also all have provider-certified consultants. Amazon Web Services has premier consulting partners, whereas Google Cloud Platform and Microsoft Azure only have registered companies and authorized partners. The certification exams for each of these three providers is really only provider specific, so it doesn't seem to offer a general benefit to choose one or the other for the training and development of Fintech's employees. With regards to security, Microsoft Azure seems to take the lead. They are the only ones that offer encryption and identity and access management. However, Amazon Web Services and Google Cloud Platform are far from lacking. They each enumerate a variety of security benefits, so unless Microsoft Azure is neck and neck with price, it doesn't really make sense to choose them just because of their security benefits. All three of these services had similar quality, customer service, uptime, reliability, and data retrievability. While there were some differences in terms of acquiring consultants to train staff in each of the services, in a longer time horizon, these differences virtually disappeared. Because of this, the question fundamentally came down to which option was the cheapest. To figure out which cloud service provider was the cheapest, I broke down the three options into their two basic components: fixed costs and variable costs. I then subdivided variable costs into average cost per gigabyte, assuming that each gigabyte cost a set amount and didn't vary with scale. For fixed costs, I found that Google Cloud has fixed costs of around $400, Microsoft Azure has fixed costs at around $300, and Amazon Web Services has fixed costs of around $150. On first glance, this gives Amazon Web Services an early lead. However, the intention of choosing a cloud service provider is to find a partner that could continue to support Fintech as it grows and changes in years to come. For this reason, I ranked fixed costs as a very low concern when choosing an ideal company for Fintech to partner with. Moving on, I determined the variable costs that a company at Fintech size would need to accrue to support their operations. For Google Cloud, variable costs equaled $1,284. For Microsoft Azure, variable costs totaled $7,001. And for Amazon Web Services, variable costs totaled $1,488. Judging purely off net variable costs, Google Cloud appears to be our best choice. They offer the lowest variable cost to support Fintech as is. However, this overlooks one crucial point. Google Cloud's variable costs get Fintech 1,024 gigabytes of storage. Amazon Web Services, because of the strange way they offer plans, is actually able to offer Fintech 1,280 gigabytes as the minimum necessary storage to host their services. This means that while Google Cloud may be the cheaper option at face value, Amazon Web Services actually has cheaper per gigabyte costs. Google Cloud's per gigabyte costs are around $1.254 per gigabyte. Microsoft Azure charges around $6.837, and Amazon Web Services only charges $1.163 per gigabyte. So, Amazon Web Services has the overall cheapest variable cost per gigabyte. Even though their net variable costs are greater upfront than Google Cloud, their per gigabyte cost is the cheapest, which makes them the best option in the long run for Fintech. To look at this mathematically, we see that Fintech's average cost per gigabyte is represented by average cost equals fixed cost plus the cost per gigabyte times the number of gigabytes Fintech buys all over the number of gigabytes. From this, we can see that fixed cost and cost per gigabyte are both in the numerator, which means that the lower these two values are, the lower the average cost per gigabyte will be as well. We can also see that total cost is a function of fixed costs and the cost per gigabyte, which means that a lower fixed cost and a lower per gigabyte cost correlates to an overall lower total cost. And lastly, we see that the change in total cost just equals the cost per gigabyte, which makes sense intuitively because an increase of 1 gigabyte would increase the total cost by the cost of that gigabyte. Thus, because Amazon Web Services has the lowest fixed costs and the lowest cost per gigabyte, they are the service I'd recommend that JoQuo and Fintech utilize to host their data and algorithm moving forward, because it will have the lowest average cost and total cost, regardless of the amount of gigabytes that Fintech needs to purchase. Now that we've discovered which of the companies Fintech should move forward with, I think it would be beneficial to analyze the pricing strategy of cloud services. And more specifically, I'd like to dive into how bundling can allow cloud service providers to sell more of their services and capture a larger chunk of the consumer surplus. In this example, we have a cloud service provider, Google Cloud, selling two products, their proprietary software and 1,024 gigabytes of storage in their database. We also have two customers, customer one, who is willing to pay up to $600 on proprietary software, but only up to 1,284 on database storage, and customer two, who is willing to spend $250 on proprietary software and up to 1,584 on database storage. From this, we can see that if Google Cloud makes no changes to their pricing strategy, they will sell customer one a copy of their proprietary software for $400 and sell customer two 1,024 gigabytes of storage for $1,384. Not only does this mean that Google Cloud is only bringing in $1,784 of revenue, but it also means that they are leaving $400 of consumer surplus on the table, $200 from each sale. If Google Cloud decided that no matter what, they wanted to sell their services separately to both individuals, they would have to sell their proprietary software for only $250, because that's the maximum amount that customer 2 is willing to pay, and their database storage for $1,284, because that's the maximum amount that customer 1 is willing to pay. However, this still leaves money on the table from both consumers. Customer 1 would have been willing to pay $350 more for the proprietary software than they ended up paying, and customer 2 would have been willing to pay $300 more for database storage. Thus, while the strategy does up Google Cloud's revenue from $1,784 to $3,068, it still leaves $650 of consumer surplus on the table. If Google Cloud bundles their product, selling proprietary software and database services for one lump sum of $1,834, then both customers will purchase the package because it is still under or equal to their total budget for software and storage. By selling this bundle, Google Cloud is able to increase their revenue to $3,668, which is $600 more in revenue than if they had sold their products separately. Furthermore, it reduces the net consumer surplus down to only $50. This example makes it very obvious how bundling products can allow cloud service providers to bring in more revenue by taking more of the consumer surplus and selling to a wider swath of customers. To conclude, let's review the key takeaways from this case. With regards to the overarching question of the case, JoQuo should select Amazon Web Services to host Fintech's customer data because it will be the most cost-effective service to scale. In addition, cloud service providers should consider bundling their services in order to make themselves available to more consumers and capture a larger share of the consumer surplus. I hope this presentation was entertaining, and I hope it enabled you to better understand fixed, variable, and average costs, as well as how bundling can work in favor of a producer.